So this is number 25 on section 5.7, and we're given a polynomial of degree 3. And because the degree is 3, we know that there are going to be 3 roots, and one of the roots is given to you for free. So let's find the other 2 by going synthetic division. So I have all of the coefficients there in place, and the given root goes on the outside. And then we drop the first number, and then go 1 times 3i. So 1 times 3i is 3i. Now, when you add these, you can't really turn it into like a single number because this number is real, this is not. So when you add these, it's not like going to be 2i or negative 2i or anything like that. It'll just be like this. And now we have to multiply these numbers here. So let me do some scratch work down here at the bottom. So I have negative 5 plus 3i times 3i. So when I distribute, that times that is negative 15i. And then this times this would be positive 9i squared. It's I squared because it's I times I. But then recall that I squared is negative 1. So the negative 1 turns the 9 into a negative 9. And this number is what goes here. And this works out so conveniently because when you add these numbers, the 9's eliminate. And it's negative 15i. And so I have negative 15i times 3i. And when you multiply these, it's negative 45i squared because it's I times I. But then I squared is negative 1 times the negative 45 turns it into 45. And that's convenient because the remainder is 0, as it should because this was a root. But then remember what we talked about in class, how if 3i is a root, then negative 3i is also a root because this was imaginary. And you always include the conjugate of a root that is either imaginary or irrational. And so negative 3i can go on the outside as well. And watch how conveniently this works out. 1 times negative 3i is negative 3i. When you add these, it's just negative 5. This times this is positive 15i, has a remainder of 0. So we have 2 of the roots. We just have to find one more because there are 3 roots. So to find the last one, what you do is you can build your equation. Recall that this 0 is the remainder, and that this is your constant, and that this is x. So the equation that comes to life here would be 1x minus 5 equals 0, or simply put, x minus 5 equals 0, and so the other root would be 5. And so all of your roots all together would be 3i, negative 3i, and 5. And I believe that the other homework question, 27, it behaves like this, where you have to do some multiplications like this. So give that one a go, and let me know if you have any questions.